Welcome back, everyone, and staying right with the theme of structural analysis, we're doing some more simulations and finite element analysis. And what's going to happen here is we're learning, whenever we do this, where the stresses are in the part. Will the part be able to withstand the force that's applied? So in this, you have to have three major components. You have to have your materials, well, of course, the design with the materials. And second, you have to have your constraints. And third, you got to have your force and where the force is being applied at. And what it does is it analyzes it, and it shows you the points where there's potential failures. And it'll actually show you with a color scheme from 0 to 8 on there where you're at far as passing the tensile strength of the material. And that's where we're calling, for us, we're going to call a failure whenever it reaches that point where the material won't bend back to its normal shape. All right. So really, you want to try to keep your part above a 3.0 on this safety level. Anything under 1 is going to fail. It's going to rupture and break, okay? But you really want to stay, you don't want your part to be all in the blue. You want it to be, in the greens and some yellows. That way you don't over design the part. All right? And that's our whole focus here in additive manufacturing, is that we're trying to produce parts that are lighter, and they'll have some different shapes, kind of not the usual shapes we see, like this bracket here. It's just straight lines. Well, you don't need all that material to get the same level of strength. So we're going to cut and carve on this to try to eliminate some material. And when you 3D print, and you all know this by now, we've been doing this, 3D printing is a slow process. So the less material that we print, the better off it's going to be. It's going to be more efficient for us, and especially if it can do the same thing, with less material and less time as this can be. This just standard conventional bracket. Okay, so let's jump in there and let's do this. You guys have already been doing some of it. First thing I want to do is make this out of, we're going to make this one just out of ABS plastic, okay? So I just come up here and right click on Project 7A. That's what I've called it after I saved it. And we'll come down here to physical material. And in this part is where I go in and I find my ABS and plastics, okay? Plastic, ABS plastic, and put it right over top of that. And that is there. I want to hit save. Okay. Now, anytime you make an update to your project, let's say for instance you would done an analysis on this and it didn't withstand the pressure, and you want to change the material on it, you'll have to come up here and hit modify, and you want to let's see here. Well, I didn't make enough of a change on it to do an update, and I'll show you all that. Just, well, go ahead and hit compute all. And what that does is it changes the design to compute all, and that works with our analysis here in simulation. So anything you do, you need to go in there and hit compute all to change it, okay? It just changes the parameters in the design. So now I want to switch from my design over here on the left down to simulation. And inside here, we're going to just do static stress. That's all we're working with is statics. And on this part, I'm going to put some pressure on it, okay? But first, I'm going to lock it down. So I got the material. The first thing's taken care of. The next thing is to come in here and put a constraint on it. So go to structural constraints. And on this one, I'm just going to use, now, you've got different ones. We could use pin if you wanted to, and I'll show you that. You just come in here and it's like it's pinned. Now, if you put that pin constraint in there, it won't move from side to side, but it will rotate. Okay, if you put another pin in it, it won't rotate. But for what I'm going to do, I want to do fixed. Okay, on both of those, I just want to constrain it straight in. And let me cancel that out. Let's see if that's stuck. All right. So to tell what's going on, this is study 1 that we've started out with. And loads constraints. So no, it didn't save my constraint. So I've got to go back in there and do it again. I'm just going to use a fixed constraint, and I'll click on that, and then I'll click on this one, and then you have to hit OK on that. So my constraints, I'm locked. Y'all see that? So I'm locked. And the reason I wanted that is I just didn't want this thing to uplift as it's being pushed on, okay? Now, the next project you do in 7B, you will be using pins in that, okay? So that's how that you do the differences in them. So now, with that done, let's put a force on this. We're going to put 1,200 newtons on this, which is equivalent to about, you done the calculations the other day. What was about 200 and around 270? I'm just guessing, around 270 pounds. So we're going to put about 1,200 newtons on this, and it's right here in loads, structural loads. All I do is hit the face of this and put 1,200, and OK. Y'all see that? So this thing is all ready. You all see it over here. I've got my loads. If you right click it, everything should be, if I click on this, you can see the force. I can edit it by clicking on it anytime I want. Same thing down here with constraints. I can click on it and I can change those at any time. So that's the beauty of using parametric modeling software. So we are ready. Come up here and check and make sure you got everything correct. The study setup has all the information required, and when it does that, I can go over here, results, structural results. Well, I could have hit analysis there too, but I hit yes, and I'm going to solve here for this, okay? So let's see what's going to happen, all right? Okay, the study is complete, and if you look, I got a 0.45. I'm in the red, so there's something that happened. Oh, wow. Check it out. Like I said, you don't want a whole lot of blue, but you don't want red, and you don't want a lot of yellow. You want to be more around the green to yellow, a little yellow, but you don't want a whole lot of blue. But you're noticing this. Check this out. That pressure is being applied. Look how much this is bending from the pressure. And ultimately, when it gets to that point right there, it's done, okay? It's going to fail. So right here we see some major problems. And like I said, you need to be up close to around that 3 mark, okay? That's where we like to be. So what we're going to do is we've got to go in and redesign this thing. Okay, we're trying to cut out a lot of material that we don't need, like this blue section up here. And down here, we don't need all this blue, you know. But there is a requirement for length out here, but we could cut into it. You know, we can cut into this too. We could add a few stiffeners in here for this little section. A fillet would be great right here, and maybe some extra material here. Whatever you see fit to make this thing better, that's what we've got to do. So I want to finish the result, and also I want to go in and I want to look at, and I can go back to the study right here, and and I can look at the report. Right here it is. And I want to look at the report, and I want to see, and this is what I want you guys to take some snipping pictures for me. Take a couple pictures. One of them, I want you guys to make sure that you show me your material. See, I'm using ABS plastic, and the yield strength's 20 MPa, and my tensile strength, the ultimate strength, is 29.6, and I misspoke a few minutes ago, but it should be the yield strength is probably what we have this thing set to fail. And basically, you never want to go past your yield strength on anything you design. So 20 megapascals is what that is. And you come down here, this is how we had it fixed in. This is the pressure that's being applied to it. We come down here, and the displacement. This is how much this part moved at the top end. So it's moving a little over 5 millimeters. Y'all see that? Wow, mostly in that z-axis that we were pushing on it. And what that means is 5 millimeters. Let's get a good shot of it. Probably right. Let's go back to our drawing here just a minute. Well, anyways, it would be from the point of natural, the part just set naturally, and to the furthest point that it's being forced, the movement, it's 5 millimeters. So that's your displacement, and we'll look at that in just a minute. The reaction forces here, wow, y'all see all this, the strain, all of it's in here, and you're looking at some major numbers in here. It's a lot more than what my part could handle, and you all can see it. And again, right here would be the displacement. Right there on that point of the natural state of the part to the same point after it's been the force applied. Okay? And that's what you're getting at. And you've got all kinds of cool things here to study and to look at. So again, I want you to take and make some pictures and add that to your submission forms before you turn it in. But I've got to do some work on this thing to make it right. Let's go in and see what we can do. I don't want to change material. That's the last thing I want to do. You know, in additive manufacturing, you're trying to make the part as simplistic as you can, and it can be very, very complex because you can make it with this technology. All right? So you don't need to just add another material to it to withstand that. We could make that out of steel and it would have withstood that. But I want to make it out of a plastic, but I want to design it to where it can withstand that pressure. So let's go back up, design, and now I take a look at it, and I want to add myself a fillet, a nice little fillet here, and I'll click on this line there. And what kind of fillet do I want? Let's see, maybe about 15. That might be too much. That might interfere with something. Let's go about 10. Okay? That'll make a lot of difference there. Now again, remember this all up here was in the blue, so it was no real heavy stress at all in this section and this. So what I do, I want to make myself a sketch here. And well, before I do that, let's do this. Let me go back. I can just hit undo a couple times. I'm going to put a fillet up here on the top portion of this. Alright, we'll put a fillet there. We'll put 15. Okay. Why not put another one on the other side, 15? And again, this thing has to be that tall. So I want to do this. I want to come in here. I'm going to just do some crazy design. Just come down a little bit. Or it might be better off if I done like an arc, like a 3-point arc. I catch that point to that point. That'd give me the height. I come down just a fuzz like that. And I'll extrude that out. Okay. And then just to clean it up, you can put some fillets on this thing. Like, oh, I didn't want to do that much. 5. Do the same thing over here. fillet of 5. Perfect. Alright, looks kind of crazy, doesn't it? Now, what else? Down here at the bottom, we could actually do something like that. Click on this, and this is your all's design. I want you guys to design it however you want, just to make this thing work so that we can get it above that safety measure of 3. And I'll come in here and put another one in, something like that. But what I got to do too, make sure we're concentric here. I'll do 12, and I'll do 12. Finish the sketch out. I'll extrude this piece out all the way. Alright, and I want to put, you know what else I want to put? I want to put a rib in here, like a stiffener. Alright, so it's not going to add a whole lot of material. I don't want to put too much material in, but I'll come up here to construct, and I'll do a mid-plane. I'll catch that. I'll catch that, and okay. And now I want to do a sketch on that plane. And I'm just going to come in here a little ways. And I've got to project that geometry up. So just come in here, project. There, and there. And I want to just, I don't want to add too much material, guys. I just want to add a little bit. And I'm just going to bring that back in there so it all ties in together. Finish that out. And extrude. And undoubtedly I didn't catch everything. So I need to go back in there to my sketch, double click it. And that's what happened. Trim. All right. Double click, and I want to go in here and I want to slice so I can see what's going on. All right. I want to delete that line out now, delete that line out, delete that one. And let's see what's going on with this thing. There we go. Got that line in. Delete that line out. And I'll put those two in, finish my sketch up. And now I think we've got something. There it is. Beautiful. 2 sides. I'll do 2.5 on one side, 2.5 on another. And that looks great. See what I done? Go back. 2 sides and make sure that you're not cutting it, but you're actually do 2.5, 2.5, and make sure you're not cutting it, but you're joining it right here at the bottom. Okay, if you want to do, now this is your design, however you feel. And also, I want to put a little bit more material. Right here was the real rough zone. So I'm just guesstimating what I need to do here. I'm going to use a spline. And what I'll do is I'll start about right here. I'll bring that right across here like that. I don't want to add in too much material. Okay. I'll cut that right down through here. Start turning it about right there, and I'm just going to thicken this up a little bit through there. Okay, so finish that sketch out, extrude. I'll extrude it about 1 millimeter. All right, I might put a taper on it, about 10 millimeter taper on it. Let's see what that looks like. I put it the wrong way, be a -10. -10. That looks good. So what I want to do is put it on the other side. The reason I only done one side is keep it symmetrical. That was it. So again, I want to put in another mid plane. I'll catch that. Into that, I got me a plane. And now I can use my mirroring tool to go in here and it's right here in create mirror. And I want to catch that. See, I'm clicking on it down there. I could have clicked it up here too. My mirror plane is this guy right there, and then OK. It all blends together. Oh yeah, it looks good. So I've got all of this done, and I just hid my plane there. So now let's see how this thing holds up. Okay, and then we can do more modifications after this. So I want to go in, and like I said, after you get done, you have to hit modify, compute all. Okay, let's go down here to simulation. And I want to do another study. This is study 1, the first one I did. This is study 2, the new one. And you got to go back, create another study. You got to go in and put your constraints on again. And we did this one like that, and then OK. And then I want to put my forces on, loads. Right here on the back of this, 1200 newtons. And that should be everything. It's still the same material. It's still, we didn't change that. I want to check and see what this is like. Perfect. And now, let's go over here and hit simulation results. All right. And I always hit that, but I mean, I could come over here and hit these other. You go to analysis and all that good stuff, but I'm just going to hit my simulation results. Yes, I wanted to do one, and I want it to solve. And right here is solve as well. So it is doing its study right now. It will get back to me. It takes just, you know, like I said, sometimes it takes 1 or 2 minutes. Sometimes it takes more. But right now we've got it set up just on standard mesh. And like I said, the more detail you put into a print, the more you need to refine and make a smaller triangulation mesh so it's a little bit accurate. And I'll show you that when this finishes up here. Alright, the results are in, and this is the second study, and let's see what happened. On this, close. Oh, let's see here what's going on. As you all can see, I'm getting closer. Do you all see that? Getting a lot closer. There's a few areas that still are in the red, and you all see like this area right here, it's ready to bust out. Any part that you have the red, it's ready to pass its yield strength, and that's why it doesn't matter, you know, about the rest of the part. Now sometimes you'll have a little bit of red, like little spots. It doesn't really mean anything. But 0.46, there's still issues with this part. And you still see some blue. Now this is looking better on this other side over here. Maybe we can put a fillet over here, you know, to cut back some material. Up here at the top, we can alleviate some more of this blue area. But the problem of it is right here in our red zone, we've got to stiffen this up a little bit more. Maybe add a little bit more thickness to this or something along those lines. But it's giving us an idea of where we're at with this thing. And you can see here, look at the, you know, the force, look how much displacement. And if we go in there and we look at the results, we can see, and here of course is your animation. You all remember that. We done that before. But we can turn it, and as the pressure is applied to this, you can watch the animation. And you can make a video of it too. Here comes the force, what's on the other side of it. Here we go. Let's turn this around so we can see it. Alright, there we go. And you can see as you push, oh, there comes the pressure. Uh-oh, right here comes the reds, okay? So that helps you to see. Now, if we want to look at our results, we can, we can look at a report right here. You can also look at your report down here, in your study. There should be a place for your report. But we're going to preview it. We come down through here, and of course, you'll see all the information. Once you guys get this to about a 3, I'm looking for about a 3 on that. Then I want you to take pictures of everything, and then I want you to come in here and take pictures of your results, okay? But now let's go back to our drawing. And I'm finished with my results, okay? Now you can go back to those results at any time. You've got 2 different studies here. Y'all see that? There's 2 different studies. You can get in there, right click, and go to the report and look at all that. But now I want to show you all too. Here's that, what I was talking about, a mesh. If you edit it, if I come in here and go about halfway, well, before I do that, if I right click and go generate mesh, it'll show you the mesh, the triangulation of this part. This is how it's triangulated right now, which is good. If I go in here and edit it and go about 5%, somewhere in that neighborhood, maybe a little less, and then I right click and I generate the mesh with a smaller density, you all see that? That will be your mesh, and that's how it's going to calculate. It's going to take a lot more time, but especially for really fine details, it does a better job in getting the calculations pretty close. So folks, what I want you to do is I want you all to take your design, like I said, and start cutting away at this, cutting and carving and adding. There's no rhyme or reason. It doesn't have to be pretty, but it just has to work, okay? That's the main thing. And again, I want your guys' results, I want them to be right around that 3 range right here. Now it could be just a little under, it could be a little over, but I like to see we can see some blues. I just don't want to overbuild this thing, and I don't want to see a whole lot of yellows, and I surely don't want to see red. So, try to keep it between the green and the yellow here the best you can. And if you can get it around 3 for your safety factor, you've done well. So it's a good project. Get in there, get working on it. If you need my help, just let me know.